All right, here we're going to find the area between two curves. So first off, we're going to graph this function. So go to your graphing calculator and type in what's easier than negative 1/2, negative 0.5, right? X squared. Make sure you come down from the square, minus 2x plus 4. Awesome, enter. There we go, a parabola. We can do that. Find the value of negative, oh, we're supposed to graph it over here, of the integral from -5 to 0. Using one color, shade the region for which this value represents. Well, let's get my graph onto the paper. So by doing that, we're going to go to Menu, Trace, Graph Trace, and let's pick up the spider. Now we're using one color, so I'll use blue. And let's go back. I'm going to type in, watch how I'm going to type in -5, enter, and that's at 1.5. Let's go to -6, -2. So -6 at -2, -5 is at 1.5. How are we doing? Good? Okay, -4 is up at 4. These are nice integers going on here. -3 is at 5.5. -2 is that 6? You know what? Remember what we could have done is we could have done a little table here. Let's see. Now I'm going to use symmetry to find the other points. So after the vertex, the points should all be symmetrical, and I could check that. Let's just type in 2, make sure I end up at -2. Yep, good. All right. Now, using one color, shade the region for which this value represents the area. It says find this value. Okay, I'm going to show you guys a neat trick in the calculator. Okay, ready? Do you see how this is in f of 1? We're going to insert. How do I insert a calculator? There go my lights. Let's go Control I, insert calculator. Okay, now I want the integral. Remember, I wasn't sure if we had to do it by hand, but we'll use a calculator for this. And I'm going to do the integral from -5 up, up, up to 0. Now, instead of retyping it in, watch what I can do. There's this button called var. I'm going to go pick it up. Pick up, if you click var, do you see how it says, hey, do you want to use F1? I said, yep, because I put in this function into F1. So F1 of what? Well, it's F1 of x, and I want to integrate with respect to x. Isn't that neat? So where did that come from? That came from var. var stands for variables, and that's where your calculator is storing all the variables. Using one color, shade the region for which this value represents the area. So that's from -5 to 0 and only to the x-axis, right? So we're supposed to shade, but I don't know if I have any colored, I have green, which doesn't match my blue at all. So it started at -5 and we went to 0. All right. Okay, what are we doing next? Graph this function on the same grid above and find the value. Oh, okay. So how do I go back to my graph? I'm going to go Control left, and that switches me back. How do I get a new function? You hit Tab, and there you see we're at F2. So F2 is going to be 0.5x plus 4. What is that going to be, a parabola or a line? Oh, that's going to be a line. And I'm going to go to Menu, Trace, Graph Trace, and let's type in negative. You know what? We're tracing a line. Do we really need to trace a line? It's kind of silly, huh? -6 at -2, but then the slope is up 1 over 2. I feel like, oh, I feel like this is wrong. Because where is it tracing? It's tracing the wrong function. How do I trace the, oh, there you go. See that? See how I was tracing the wrong function? So -6 is actually at 1. And then from there, it's up 1 over 2. And we'll see if we get the correct y-intercept. Is the y-intercept 4? Yes, it is. Yes. What do you guys say now? Yes. Yes. I can't say that. All right. So there's that. Yeah? Okay, what are we supposed to do? Graph this function on the same grid above and find this value. You can do it by hand, but let's practice using the calculator. So I'm going to go Control right and pick up the integral, Control times. We're going to go from -5 to 0. And now instead of using F1, I have click var and I have F2 now. Now if you're watching me do this and you're not practicing yourself, you won't be able to do this on a test. So you should be practicing this yourself. I know I'm going fast, but you can hang your AP Calculus students. 13.75. Using a different color, shade the region for which this value represents the area. Okay, hold on. So this value is from -5 to 0, from the g function where? Down to the x-axis, right? So it's between this line and the x-axis. Isn't that a trapezoid? Yeah? Okay. I did that. What do you suppose you would do to find the area of the region that is located between the graphs of f and g? Between the graphs is going to be this area right here. Sorry about the video there. Okay, so we're going to find the area between. So do you see how that part was double shaded? We don't want that. We want this part, the area between the parabola and the line. Well, what can you do with area? Can't you add and subtract it? Right? So we're going to take 24.1667 and subtract 13.75. So let's see, is there a shortcut? I'm always looking for shortcuts in the calculator. Can I do this? I up and press it, and then I press enter. Look at that. Man, I love copy and paste. Okay, minus up, and then I press enter. You just press enter to get that value. All right. Great, we found the area in between. Now what? Units squared, because it's area. Now find the value of the definite integral below. Okay, sorry, this is a silly video. We are going to find the value of the definite integral below, but we're not going to show our work. We're going to use it. Look, I tried to show my work and I made a mistake. So we're going to use a calculator. Okay. So this in the calculator. Are you ready? We're just going to do it in the calculator. The integral from -5 to 0 of the first function of x minus the second function. And then you're going to notice something. Enter. Dun, 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 dun. Okay. So what do you notice? When you take the two functions and subtract them, we get the same number. So it's same as before. So how do you suppose we find the area in between the two curves? We subtract. So let's write that down on our next page. Okay, so to find the area between two curves, it's very simple, you guys. You're going to like this lesson. All you do is you go from A to B, and it's one function minus the other function. But the one thing that matters is that it's always top minus bottom. Remember a while ago I said you're going to know, or we're going to use top minus bottom again. Here we are, top minus bottom. A and B are the x values of the intersection, and f has to be greater than g because that's top minus bottom. Okay, so this is non-calc. All of these are going to be non-calc or calc, and it will let you know. Find the area of this shaded region. That's cute. You can make up what you think it looks like to you. And it's bounded by the sine curve and the cubic. You have to figure out, based on this picture, which one's on top and which one's on the bottom. So does sine, does it go up or does it go down? it goes up from the origin. So the top function is sine, and that matters. And the bottom function is the cubic. So where does this start and where does this end? It starts at 0 and goes to 2. And we have the top function minus the bottom function. Okay, tell me what my mistake is. Do you guys see my mistake? I did the top function minus the g function, but the g function is in 2 terms. So we either have to put parentheses or you need to distribute. You have to distribute that minus sign. You ready? Here we go. Do you know what we need to be doing? We need to be saying the area equals this, the area. Because the next lesson we're going to find volume. And if you don't tell the grader what you're finding, you're going to get it wrong. So you have to have A or A. Okay, this one's a non-calculator, so we're going to integrate by hand. What's the antiderivative of sine? The antiderivative of sine is cosine. And do you see how that's a constant in front of the x? So we're going to divide by that constant. That's the most basic form of u substitution. And the derivative of cosine is negative sine, so we need to add a negative. Just take the derivative back. The derivative of cosine would be sine. The inside stays the same, and then you would multiply by 1 over, then you would multiply by pi. So we have to divide by pi. Do we need a plus c? We don't need a plus c because we're actually plugging in 2 and 0. All right. Okay, so let's plug in 2. And we like 2 because we have 2 pi minus 2 to the 4th power over 4 plus 2 times 2 squared. And then we're going to plug the 0 in, but be careful, the cosine is 0. You know, you can't just wipe it out like we can wipe those out. This is going to be minus 0 plus 0 though. All right. Cosine of 2 pi. So here's 0, also 2 pi, and the cosine there is 1. So we have negative 1 pi times 1 minus 2 to the 4th power divided by 4 plus 2 times 2 squared. And then the cosine of 0 is the same as the cosine of 2 pi, which is 1. We have a negative negative, so that becomes 1 over 1 pi. 1 over, yeah, did I say that right? Yes. Okay, what happens to the 1 over pi's? They cancel, and I have a negative 4 plus 8. So the area between these two is 4. So we're going to do sum by hand and sum with the calculator. I'm not going to fill these in right now. We're going to move on and try and do this. I have 2 minutes, but this is a full calculator, so maybe I'm actually going to fill these in and we'll go on to the next example on a different video.